While it's possible to manually create regions using the quantification parameters dialog window to quantify a survey spectrum such as this one, what we'll do now is look at the element library and how to manage the creation of regions based on the element library. The first thing we need to do is identify the peaks that we see here. So I've clicked on the peak, the largest peak, and it's most likely going to be fluorine 1s. So I can now see that I've put up markers that correspond to the fluorine 1s. There's an Auger peak that matches it, so that's probably fluorine, and there's another one, and that's probably oxygen. And yes, we can see there's an Auger peak here corresponding to the oxygen 1s, so oxygen is plausible, and we could go through and identify these peaks individually, or we could say find peaks. And having said find peaks, the elements that are most likely to correspond to these peaks have been identified in the periodic table, but it's also included peaks that are possible, such as this boron peak. I don't believe there's any boron in this sample, and if I look at the data, the structure that has been identified as boron is probably a lost peak associated with this sulfur 2p, and so we'll deselect that, and we'll see, just check that the other peaks make sense. There's a carbon 1s, and the carbon 1s has some structure here, so we have to bear that in mind when we create a region. And let's see now, if we look through the set, you can see that the sulfur has a corresponding Auger. Let's just verify there is some structure there. Yes, that looks like we've got some kind of sulfur structure, so that matches the sulfur Auger line, and you can clearly see a carbon, nitrogen, oxygen and fluorine that all correspond to the photoelectron transitions fluorine 1s, oxygen 1s, nitrogen 1s and carbon 1s, with the sulfur 2p is the one that we're going to use to quantify. So having identified and decided that these are all good, what we can do is create regions using the button on the periodic table, or even the one that's on the element table. They both do the same thing. Based on the buttons you see highlighted here, a set of regions have been created and a table has been placed over the data. Now, there were 5 peaks identified, 5 elements: oxygen, carbon, nitrogen, fluorine, and there was sulfur, but sulfur has not had a region created, and the reason for that is that when I bring up the sulfur line for the 2p, you can see that there's a significant gap between where the element markers are and where the peak is, and that's understandable in terms of the chemistry. This is going to be a sulfate-like peak, and the line has been entered into the element library that is consistent with a sulfide, and sulfur does respond by energy shifts according to the chemistry. So there's a good reason why it didn't find it, but the problem is that having not created a region, we now need to create a region, and we can do this by manually entering, using the element table, an entry for the sulfur. So if I select in the element library, you can see the relative sensitivity factor here. The reason that I have to select it is because the survey spectrum is in a VAMAS block that knows nothing about the actual elements that the data represents. Unlike some of these narrow scans, this is supposed to be a fluorine. This survey doesn't have the same context information, so in order to create a region here, I have to indicate the element, and I have done with this sulfur 2p, and then I can say create, having indicated on the element table. We'll create a region, and the region is based on the display limits, so I need to just adjust so that I've got a region that then is the peak itself, and you'll see the sensitivity factor is the same. It's got a Shirley background, that was the last one used, and we've now see that it's added to the table, and I've got a quantification based on the regions as created so far. Now the one that I had a query about was going to be the carbon 1s, but we can just check all of them by pressing the reset button and then zooming out. It'll step us through the different regions. Now this is nitrogen. It's got some structure here which is consistent with the nitrogen chemistry. We won't worry about that. But the carbon, we've got carbon here, and then this is also carbon, probably bonded with the fluorine. So if I need to include that in the quantification, so I adjust the region, but you can see now that a background based on the Shirley background cuts through the data, and so it's not a good estimate for the peak area. So what I'll do now is make a small adjustment. So I'm going to actually I'll delete that so I can keep my carbon peaks all together, and I'll recreate a carbon peak over here. And I'm going to create one that is for the small peak, and then I'll create another one. This is going to be for the larger peak, and again I'm going to, so I've got two regions now to define the background, so I need to add these two intensities together to find the amount of carbon that I've got. So it's these two numbers here must be added together to give me the carbon. Now I could also do another little trick. I could create another region, and again I want this to be carbon, and I'm going to call this region 1, this one region 2. I'm going to set the RSF to 0 in that, the RSF to 0 in that, and the trick is to change the background type. Instead of having Shirley, where it's now calculated a background that is cutting through the data again, if I change that to skip, what it allows me to do is to use the background that has already been calculated. So these two, although the RSFs are set to 0, the background is a Shirley in one and a Shirley in the other, two regions independently creating backgrounds, but with no contribution. As you can see, 0 and 0 for the concentration, but the one peak that I've got a skip background is using the existing background that you see here and integrating the signal above that background and reporting the result here. So we now have the amount of carbon is now deriving from this skip background region that is across both. So if I click on where it says G, it'll zoom, and so you can see that's both of them. If I click on where it says F, it shows me the one part of the peak, and there's the other part. So G encompasses both. So now you can see the report, and here, because this is a regions report, it's actually showing you all the regions, even though we've got zeros here. Now if I wanted to see a report that is just going to have the values that have RSFs that are assigned, in other words the ones that will give me a contribution to the atomic concentration calculation, then I can create from the annotation dialog window, rather than using regions, which is what you can see already, I'm going to go to the quantification tab, which will rely on what I've got selected in the right hand side. It's got regions selected, and I can set myself a font and then say apply. And you can see I've got two sets of annotation, and what I need to do is just scroll out a bit because my region was overlapping that. If I now point at the annotation marker and move it, you can see that I've got two tables. One is the original one, and because I clicked on it, it's come to the top of the table here, and if I click on that one, it'll come to the top, and that's the one that I've just created. And this one now shows you just the carbon that is deriving from the region that had a a non-zero RSF. So what I'll do now is just delete this table here, and we now have a quantification report that I can then copy, and I can put that into some other program. So there's a report coming from the survey spectrum based on these regions.